Hello, I am Mariana Ceballos, and this is my experiment. How will copper sulfate at various concentrations be absorbed by and affect the growth of allodia plants? Intro. Dissolved oxygen plays a crucial role in all aquatic ecosystems. Without enough of it, many aquatic organisms, such as fish, would not be able to survive. The main sources of dissolved oxygen originate from surface winds and, of course, photosynthesis performed by aquatic plants. Unfortunately, pollutants such as toxic metals can inflict damage on, and under certain concentrations, even kill these aquatic plants. To ensure that O2 levels in aquatic ecosystems are high enough for the survival of organisms that live there, it is necessary to protect aquatic plants as one of the primary sources of dissolved oxygen. The hypothesis for the experiment is, if the concentration of copper sulfate is 5 ppm or higher, the allodia plant will be unable to absorb the chemical waste to stay healthy, and so the dissolved oxygen produced by the allodia plant will be decreased to a level insufficient to sustain a healthy aquatic environment. Here are the procedures for the setup of the experiment. A total of 24 closed containers were set up with 300 milliliters of water and one allodia plant each. There are 4 instances for the experiment. There were 6 containers for 0 ppm copper sulfate, the control, 6 containers for 1 ppm copper sulfate, 6 containers for 5 ppm copper sulfate, and 6 containers for 10 ppm copper sulfate. All 24 containers were set up on the same windowsill at an equal distance from the window, as can be seen in the picture. Here are the procedures for the measurements taken during and before the experiment. For measuring copper sulfate concentration, 2 RGB photoanalyzer apps were used on an iPhone. App 1, Color Analyzer, and App 2, Pixel Picker. A mass spectroscopy chamber was used to calculate RGB values at various concentrations within 0 to 10 ppm copper sulfate before the experiment to create a calibration chart for reference. And during the experiment, measurements of the RGB values of all containers were taken once every 2 days, starting the day of setup, during a time period of 2 weeks. Below you can see an example of how RGB values were measured during the experiment. For measuring allodia biomass and length, a triple beam balance was used to measure the mass of allodia in grams. A ruler was used to measure the length of allodia in centimeters. And as for the RGB values, measurements were taken for each of the 24 allodia once every 2 days, starting the day of setup, during a time period of 2 weeks. And you can also see below an example of how these measurements were taken. And to the right is the setup of how the measurements were taken with a triple beam balance, a ruler, and the orange behind to do the mass spectroscopy chamber RGB concentration measurements. Here's the data analysis for the RGB values. This is for the calibration curve before the start of the experiment. And as you can see, only the blue values were used. This is because out of the RGB measurements, the blue values were found to be especially correlative to change in concentration. So, for all the graphs shown in the rest of the PowerPoint, only the blue values were used, as they were found to be the most crucial ones. From 0 to 10 ppm copper sulfate, the corresponding average blue values varied from App 1, 55.3 to 42.6, and App 2, 54 to 50.6. As the concentration of copper sulfate increased, the blue values decreased, and this is shown in both graphs. This is where we use the calibration curve shown earlier. We used the graph shown earlier to create a calibration curve based on the absorbance. The measurements of the blue values taken before the start of the experiment were used to create a calibration curve of the absorbance factor corresponding to copper sulfate concentration. Negative logarithms were taken of the values, setting the control, 0 ppm, value to an absorbance factor of 0 to get the absorbance factor for 1, 3, 5, 7, and 10 ppms. And as shown in the graph, both graphs to the right. And these are the blue values taken during the experiment. The initial blue values measured during the experiment were more or less consistent with the calibration curve previously mentioned. For all 4 instances, except for the control, the copper sulfate concentration decreased from the start of the experiment to the finish. The 0 ppm, as stated, stayed at 55.3 throughout the experiment. The 1 ppm went from 51.3 to 55.3, 5 ppm, 44.2 to 48.8, and 10 ppm, 41.8 to 46.7. This is shown in the graphs to the right. And now we will talk about how we use this data to create a calibration curve during the experiment itself. As done for the calibration curve prior to the start of the experiment, The average blue values measured during the experiment were also inputted into the absorbance graph using the negative logarithms described earlier. The absorbance factor for all 4 instances for both apps was closest to 0 at the end of the experiment. This can be seen in the graphs to the right. Here are some important details from the graphs. The control's absorbance factor did not experience major changes from 0 from the beginning of the experiment to the end. This should be expected. So, any minor deviations from the value was probably due to human error. The 1 ppm's absorbance factor started at 0.03 and decreased to 0 by the end of the experiment. So it can be inferred that the allodia in these containers were able to absorb and eliminate the concentration of copper sulfate present. However, for the 5 and 10 ppm containers, the absorbance factors started at 0.10 and 0.12 respectively, and only decreased to 0.05 and 0.07 respectively by the end of the experiment. So it can be inferred that the allodia in these containers was unable to absorb and eliminate the concentration of copper sulfate present. This is data analysis for allodia growth. To have a note before the values are shown, we should talk about allodia disintegration. It should be noted that a number of allodia disintegrated during the experiment, which had an effect on the data obtained. 2 out of the 6 of the allodia in the 5 ppm containers fell apart, and 3 out of the 6 of the allodia in the 10 ppm containers fell apart. So, as you can see, as the concentration increased, there was a higher probability that the allodia plants would disintegrate. Biomass. Allodia biomass was measured in grams during the experiment. At the end of the experiment, the final mass of allodia on the last day of measurements was divided by the initial mass of the allodia on the first day of measurements, and this was used to find the percentage of original allodia biomass present at the end of the experiment, done for each of 24 allodia plants. The control and 1 ppm containers were very similar, with 129% and 127.9% respectively. And the percents are indicative, as said earlier, of the original allodia biomass present at the end of the experiment. However, as there was allodia disintegration in the 5 ppm and 10 ppm containers, the average percentage of original allodia at the end of the experiment was actually below 100%, at 89% and 79% respectively. So as to say, less of the allodia was present at the end of the experiment than at the beginning due to the disintegration. Now for length. Allodia length was measured from one end of the stem to the tip in centimeters during the experiment. At the end of the experiment, the final length of allodia on the last day of measurements was divided by the initial length of the allodia on the first day of measurements. This was used to find the percentage of original allodia length present at the end of the experiment, done for each of 24 allodia plants, as done for the mass. The control and 1 ppm containers, again, were very similar, with 103.5% and 102.8% respectively. However, as there was allodia disintegration in the 5 ppm and 10 ppm containers, the average percentage of original allodia at the end of the experiment was actually below 100% again, at 91.3% and 83.2% respectively. And this is shown in the graph to the right. Conclusion. It can be safely said that the allodia exposed to 0 to 1 ppm copper sulfate will not experience severe harmful side effects as a result. A suggestion to change the experiment for the future could be that the experiment could be altered to include containers ranging between 1 to 5 ppm to provide more accurate findings on where exactly the copper sulfate concentration inhibits regular allodia growth. However, for the findings of the experiment, it can be seen that the allodia subjected to copper sulfate concentrations of 5 ppm or higher experienced stunted growth and/or decay at some point during the experiment, which supports the initial hypothesis. And the hypothesis was that allodia exposed to 5 ppm or higher concentrations of copper sulfate will be unable to effectively remove the chemical from the water, will be unhealthy, and will be unable to produce adequate amounts of dissolved oxygen necessary for the aquatic environment it is in. And in contrast, the allodia at 0 and 1 ppm copper sulfate was able to eliminate the copper sulfate concentration in the water, as the absorbance factor was at 0 for both at the end of the experiment. Thank you.